everyone, welcome to a new video on AI World for You. In this video, I would like to explain about A-star algorithm with an example. So let's get into the video. First, this A-star search, it comes under informed search strategy. Previously, I have discussed about uninformed search strategies like BFS and DFS. I have shared the video links in the description. You may go through them. So this A-star search, what is it exactly? A best first search because it will look for the path which is of least cost. Generally, when we say that we have informed search strategy, some information is known to the agent. This AI agent can take the next step based on the information. That's why we are calling it as informed search. What type of information is available? Heuristic value is available with the agent. This heuristic function or heuristic value is the estimated cost of the particular algorithm to reach the goal state. So this information will be provided to the agent and it will be asked to traverse through the tree and find the goal state. The main function which we will use here is the cost function, which is updated by g of n plus h of n. So we will say f of n equal to g of n plus h of n. This is how we obtain the cost function. So this cost function is also known as fitness number and it is the estimated cost of the cheapest solution to reach the goal. Also, g of n is the actual cost to reach a particular node from the start state or the initial state, and h of n is the cost to reach from the specific, that is the current node, to the goal node. So suppose I have a tree here. I have a state A and from A I am going to traverse to B. Okay. So here I have a path cost of say 5. Now in this edge I am mentioning the value 5 and near B I am going to mention a value 4. For example, this 4 is nothing but the heuristic value and this 5 is nothing but the actual cost incurred to travel from the start state A to B. So here g of n will be 5 and h of n will be 4. Is it clear? So this is the algorithm of A-star search. First we have to place the starting node in the open list and then we need to check if the open list is empty or not. If the list is empty, then we need to return failure because nothing is there for the algorithm to execute. Coming to the step 3, we need to select the node from the open list. This step 3 will be executed only when the open list is not empty. If it is empty, it will return failure. If it is not empty, then it will check which node is there in the open list and it will check the smallest value of evaluation function, which is g plus h. So if node n is the goal, then it will return success. Once the algorithm is able to traverse to that particular node and if that is the goal node, then the algorithm need not search further, right? So it will return success and terminate. If that is not the goal node, then we need to expand that node n and generate all of its successors. That is, we need to penetrate into its successors and go deeper and explore all the successor nodes and then put them in the open list. The successors will be in the open list, but what about this n? Since it is already visited, we will put it in the closed list. Then coming to the next step, if node n is already in the open and closed, then it should not be attached to the back pointer which reflects the lowest g of n value. That is, if that specific node is already visited, then we need not visit it again. So we need to repeat these steps. That is, we need to go back to step 2 and do all this again until we reach the goal state. Now let us see one example of A-star search algorithm. Here I have one graph and S is my start node, G is my goal node. Here in the edges a numeric value is assigned. So here I have 1, 2 and from A to C I have 1, from C to D I have 3 and B to D I have 5 and same way from C to G I have 4. So all the edge costs are mentioned and from S to G I have 10. So in this case the heuristic values are given in the table. So for S, for the state S, the heuristic value is 5 and for the state A, the heuristic value is 3. For B, it is 4. For C, it is 2 and for D, it is 6 and for G, it is 0. So now how to start? We need to start from S. We have two ways of approaching the problem because there are two ways for the graph to traverse. One is from S to A and the other one is from S to G. So what we need to do? First we need to find the function f of n is equal to g of n plus h of n. So now we initialize the start node and from S we are going to find f of S to A, which is nothing but 1 plus the heuristic value of A. What is S to A? Actually the path cost they have mentioned as 1 and the heuristic value of A they have mentioned as 3. So 1 plus 3 which will give us 4, right? So from S to A the cost function f of n, or you can call it the fitness number, is nothing but 4. Coming to S to G. S to G the path cost is given as 10, which means g of n value is 10 and at G the heuristic value is given as 0. So it will be 10 plus 0 which is nothing but 10. In these two if we see which is the least value, is 4 lesser or 10 the least number? 4 is less than 10, right? So the algorithm will begin to explore the path A because this particular path is the least cost one. It will choose to explore this first. So from A, what are the possibilities for the graph traversal? From A to B and A to C. So now we need to check S, A, C. So for S to A to C, what will be the total fitness number? It will be 1 plus 1 because I have two edges and both the edges have the cost here. I have 1 and 1. And for C, the heuristic value I need to consider as 2. It is given in the table. So 1 plus 1 plus 2. So I will get 4. Next, I need to calculate S to A and A to B. So there I need to consider these two path costs, that is 1 as well as 2, and the heuristic value of B is going to be 4. So it will be 1 plus 2 plus 4, which is nothing but 7. Next, I need to consider the other one, which is S to G. It is already computed, so we can ignore this. Coming to the next iteration, we have next path which is from C. In this particular iteration, which is the least cost one? 4 or 7? 4. So the algorithm will begin to explore the node C further. C also has two traversal paths. From C we can go to D or from C we can go to G. So now the algorithm needs to explore both these. So S to A to C and C to D. What will be the cost? 1 plus 1 plus 3 plus what is the heuristic value of D? 6. So it will be 11. And S to A to C and C to G, that is another combination. For that we will get, has it been computed? Yes. S to A to C, C to G, we are getting 6. How? Because S to A the path cost is 1. Then A to C path cost is 1. Then C to G path cost is 4. So 1 plus 4 we are getting 6. And what about the heuristic value of G? It is given as 0. So we are getting 6. In 6 and 11, which is the least cost one? 6. So now in iteration 4, it will directly print the result as S to A to C, C to G is the optimal path with the cost of 6. Why? Because G is the goal node. The algorithm will stop the execution here. So this is how A star algorithm will be implemented. Coming to the properties of A star algorithm, here we can say that A star algorithm is complete as long as the branching factor is finite and the cost is fixed. Suppose we have a variable cost condition, then we cannot compute the value and take a decision based on the value, right? So we need the fixed value. And commenting on the optimality, we can say that it will be optimal if these two conditions are satisfied. What are they? That is admissible. The first condition requires that the h of n heuristic value, it should be admissible. You should not give huge values of heuristic function. If they are not within the boundary, then it will cause the optimality problem. And also coming to the consistency, we can say that the second required condition is consistency for only A star graph search. So if these two conditions are satisfied, we can say that the algorithm is optimal. Coming to the time complexity, it is the same like your DFS, because here also the depth of the node is being explored first. So the time complexity is given by order of B power D, and space complexity is also given by order of B power D. Coming to the advantages, we can say that A star algorithm is the best algorithm compared to others because it will look for the least path cost, and also it is optimal and complete, and it can solve very complex problems as well. Coming to the drawbacks or disadvantages, it does not always produce the shortest path because it will consider only the neighboring states, and based on the neighbors, whichever is the least cost path, it will choose that and proceed to the next step, right? So it may not always produce the shortest path, and it has some complexity issues, and the main drawback is that memory requirement is more because each and every step needs to be stored in the temporary memory storage. So memory requirement will be more for A star. I hope you got an idea about A star search algorithm. Do let me know your doubts and suggestions in the comments. Thank you for watching.